Alright, this is Mr. Gillum, and today we're going to move on to some two-step equations. We've been practicing and practicing one-steppers, now we're going to do some two-steppers. So there's a few things you should know before we get started. When you solve a two-step equation, it's a lot like solving a one-step equation. You're going to use inverse operations, but there's going to be a combination of things you need to do. If you see any addition or subtraction to undo with their inverse properties, that's what you need to do first. If you see any multiplication and division, that's what you need to do second. Now there are exceptions to this rule, but not today. All right, we're going to talk about those exceptions after we've been practicing the standard method here. All right. Now what you'll find is when you're solving multi-step equations, you're working backwards from order of operations. So PEMDAS, order of operations. If you remember doing that in previous years, adding and subtracting is actually what's going to happen first when you're solving equations, then multiplying and dividing, and then you might have to do some distributing later, something like that. But it's going to go backwards in order of operations, okay? And like I said, there is exceptions to this rule, but not for today. Today it'll be the same every time. And as we work into distributing, you'll see some of these exceptions, and you should be able to recognize them. So let's take a look at the first problem here. As you can see, when we solve equations, we want to isolate the variable, and the variable is over here on the left-hand side this time. So I have two things I need to worry about. I have this 2 being multiplied by the x, and I see this 6 being added to the 2x term. All right, now, like I said, we want to do order of operations backwards in this case. So what I want to do is I'm going to start by subtracting 6 from both sides of the equation of the equal sign. Remember that equal sign is like the fulcrum of our balance. And so when I add the 6 and the negative 6, I get that 0 that I like to have. And the nice thing about that 0 is when I add 0 to anything in the world, it doesn't change it. So I know the 2x and the 0, they just add up to 2x total. All right, and over here, of course, 8 minus 6 is 2. So now I have a one-step equation. So now I'm getting closer to getting that variable by itself. Now, of course, the inverse of multiplication is division. X will equal 1. So we're getting better at these. And remember that 2 divided by 2 is 1, and 1 times x is x. So x equals 1. Now let me show you if you maybe didn't do it in the correct steps, what would happen. If I have the same equation, and I see this 2 in front of the x, and I decide, instead of using order of operations backwards, I decide to just do whatever I want. You can do that, but there's some rules. All right. I see that this 2 is being multiplied by x, and I want to divide by 2. You don't just divide one term by 2. You have to divide all of the terms by 2. Okay. So 2 divided by 2 is 1, and 1 times x is x. 6 divided by 2 is 3, like so, equals 4. And then I could solve my one-step equation. All right. The problem I see is a lot of students, when they're given this problem, is they're not sure which step to do first, and when they divide by 2, they just do this, and x plus 6 equals 4. So as you can see, we're going to get a different answer if I don't divide the whole thing by 2. So what I want you to do today is I want you to practice this first method. I want you to practice with doing the addition or subtraction first, and then the multiplication or division second, because we haven't talked about factoring and distributive property enough for me to be comfortable saying go ahead and do whatever you want. All right, so today we're going to start in that order. Add, subtract first, multiply, divide second. All right, you can do it this way. It's possible. It's mathematically sound, but it is not. It's not routine. We'll say that. Okay, so now I'm going to go ahead and make my little equal sign fulcrum here. And once again, like I said, I want to do adding, subtracting first when I can, and multiply, divide second. And so the first thing I need to do is I need to get this x isolated and find the solution. So I'm going to add 9 to both sides. Now that gets me a little closer to having x all by itself, because now I know that I have, oops, I don't need to write the plus on the 6. Because now negative 3 plus 9 is 6. I have one less part with over there with my variable. It's getting closer to being isolated because I know negative 4x plus 0 is still negative 4x. All right. Now, don't forget, the operation holding the 4 and the x together is multiplication. So don't add 4 to both sides. Divide both sides by negative 4. All right. X equals, now 6 divided by negative 4 may sound like, uh-oh, it's not going to work well, but the fraction 6 over negative 4 is the same thing. So we want our answers in fractions. We don't want to switch them to decimals. The fraction negative 6/4 is actually my answer, but of course I do need to reduce. These are both even numbers, so I'm going to say negative 3/2. Okay? All right, so there's a couple examples for you. Now remember, we could have done this one the same way, and let me show you what happens sometimes. If I had this negative 4x minus 9 equals negative 3, and I started by dividing by negative 4 on both sides, here's where my issues come in. That's fine, and I get the x, but now I have this negative divided by negative, which is positive 9/4 equals 3/4. And so what happens when I divide both sides first is I end up with getting fractions, and I have to do some work with fractions. And so it does work out sometimes, like you can see on the first problem, but a lot of times it makes the problem harder for us to do. So remember, I want to add, subtract first, multiply or divide second. All right. So let's do another problem, and we're going to ramp up the difficulty a little bit. We are going to throw a fraction in here. All right. So always remember, whatever happens on one side of the equal sign happens on the other side. Looks like I have this negative 2/3 times x, and I have a plus 6. Now I want to get rid of the addition subtraction first, so in this case I'm going to subtract 6 from both sides of the equal sign. Leaves me with negative 2/3 x. I could write plus 0, but by now I think we know that that's all that's left. Equals negative 7. All right. And now I have a one-stepper, but it's a special type of one-stepper. I have this fraction multiplied by x. When it's being held together by multiplication, actually the best way to get rid of that would be to multiply by the inverse or the reciprocal. Multiply both sides by negative 3/2. And I see a lot of mistakes on the positive or negativeness. I want this to be a positive x all by himself over here. So to get rid of this negative sign, I need to multiply by a negative. That'll turn this whole side into a positive term. I know that when I multiply inverses, the result is 1. Negative 1 times negative 1 is 1. Divided by 1 is still 1. So x is all that's left on the left-hand side. So I've now isolated the variable. Over here, though, it becomes a little trickier. Remember, when we're multiplying fractions, if there's not a fraction for the first number, we can put it over 1 to make it a fraction. Reduce, reduce, cross-reduce, cross-reduce. Nothing happens this time. That's all right. I multiply straight across. It's negative 7 times negative 3 is 21, and 1 times 2 is 2. 21/2 is a good answer. Okay, let's take a look at another one here. Once again, I see two things over here with the x, so that's why we call it a two-step equation. There's two things I need to do the inverse operation of. I see a positive 4, and I see a 1/5 being multiplied by x. So the first thing I need to do is I need to get rid of this 4, this positive 4. So if I don't want a 4 over there, I'm going to subtract it away. The nice thing about 4 minus 4 is 0, and when I put the 0 with the 1/5 x, it's still 1/5 x. So I've just gotten one step closer to isolating my variable, or getting it by itself, or solving for it, however you want to say it. Now remember, this is held together by multiplication, and there's a special rule when we're held together by multiplication with fractions. What we do is we multiply by the inverse, or the reciprocal, 5 over 1. I don't really need to put 5 over 1, because I know 5 divided by 1 is still 5. So on the left, I did write it as a fraction, so we can see the cross-canceling. But on the right-hand side, there's no really need for me to change both of these into fractions. It's just negative 5 times 5. So in this case, x equals negative 25. Okay. Now you get really good at these the more you practice them, and so that's what we're going to do. We're going to do a lot of practice. Let's do one with decimals. I have this minus 3.1, and I have this multiplied by 2. So the first thing I'm going to do is I'm going to add or subtract to help me solve or isolate. That leaves me with just a 2r. On the right hand side, I now have a 4.8. And remember, if you have these things, I don't want you using your calculator. I would like you to add them together. So 7 plus 1 would be 8. 3 plus 1 would be 4. My decimal place stays where it's at, 4.8. Now we practiced this skill in a previous chapter, so I expect you to be able to do that. I'm going to divide by 2. And once again, if you're not good with these mental math type of things, we did practice this long division, so if you need to do long division, that's fine as well. 2 goes into 4 twice. Bring down my 8. 2 goes into 8 4 times. With the remainder 0. 2.4. Okay, so we have done these things before. Right now I'm really concerned with you knowing the steps. So add and subtract first, multiply, divide second. R in this case is 2.4. Now let's add a little fraction problem in here. If you ask me in class, I'll show you a little trick on how to make these easier for you. But right now, I just want to kind of keep it the same. Looks like I have an addition of 1/3 and 4 being multiplied, so I want to undo the addition first with an inverse property. So I'm going to subtract 1/3 from both sides. So what I'm thinking is 4x equals 3/4 minus 1/3. So let's do a little work over here. 3/4 minus 1/3. In addition and subtraction, I need to have a common denominator. So I know that in this case would be 12. And if you need to write out, okay, I have 4, 8, 12, 3, 9, 3, 6, 9, 12. To figure out what it is, that's fine. That does not bother me at all. So 4 times 3 would be 12. 3 times 3 would be 9. 3 times 4 would be 12. 4 times 1 would be 4. So 9 minus 4 makes 5. 5/12. So I'm going to say 4x equals 5/12. Now, in order to undo this operation, I have to divide by 4. So remember I said that there's certain division signs we don't use anymore. Well, I'm going to go back on my word here a little bit. When I divide by 4 over here as a fraction, when I divide a fraction by 4, instead of making it a complex fraction, what I'm going to do is I'm just going to put the divide sign. Okay, 5/12 divided by 4. Now if you remember dividing, what we do is we change it to multiplication. 5/12 times 1/4. Alright? We change the division sign to a multiplication and we find the reciprocal of 4. And so that's how we're going to approach this. And in this case, there's no reducing. There's nothing to reduce. So I'm going to say 5/48 when I multiply straight across. Alright, so it's tricky. A little tricky. That's a hard problem. And that would be a good one to study. Okay, I just have one more problem for you to do. And it's a word problem. It says Tanya had her birthday party at the movies. Cost $27 for pizza and $8.50 per friend for the movie tickets. How many friends did Tanya have at her party? She spent $78. So in my equation, after I read this, it tells me her total spent was $78. So when I'm setting up this two-step equation, I want it all to equal 78 because that's my final money outcome. Now it says it cost $27 for pizza. So for all the pizza together, it cost $27. That's part of her ticket. All right, but it also cost her $8.50 for the number of friends she had. Now we don't know how many friends she had. That's our unknown. We don't know how many friends she had, but we do know that it costs $8.50 for every one of those friends. Okay, so for one friend, if I put a 1 in here, it would cost $8.50. If it cost 2 friends, it would be $17, and so on. So this is our two-step equation that we're going to set up. When I solve it, since we've done so many and we're running out of time, I'm going to go ahead and move through it a little bit quicker than usual. 8.50x equals 51, and then I will divide both sides by 8.5. 8.5. 51 divided by 8.5. Now, the strategy here is going to be, we talked about it a little bit in class, to think, okay, well, I know that two 8.5s would be 17, and 51 divided by 17 would equal 3. So 51 divided by 8.5 would equal 6. So x equals 6 friends. All right, one more time. I doubled this because I know 17 goes into 51 3 times. And then since I doubled this, I needed to double the number of times 8.5 goes into 51.